Alright, so title this section Venn diagrams, and so far we've looked at mutually exclusive and non-mutually exclusive.
No.
Alright,
I love
now
Venn
I'm going to erase the clutter up here, leaving the colored one,
Mine
leaving
turned
the
out bad.
one that overlaps, the non-mutually exclusive one. Now I have some questions for you. They're going to seem easier on this example than the next. So this is going to build. So I want the probability from this one of being red-headed or female. So I want to do that as a fraction. So we take the number that meet the requirement, red or female, and we divide it by the total number. So what is the total number here? 8, 2 is 10, 6 is 16. No, that'd be double counting. I'm just going to count the dots. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 total. And how many are red or female? So I get inside this circle, I see there are 1, 2, 3, 4, 5 reds, but then I see 4 more that are female. So I'm not going to double count the 2 in the middle. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. You see where I got the 9 for red or female? It's in my stripy parts. I don't know what colors you used. Alright, now I was wondering, and we kind of touched on this yesterday, does the probability of red or female equal the probability of red plus the probability of female? No, I don't think we did this one. So let's go and see. We already did the probability of red or female is 9/17. What's the probability of red?
It's not. Answer no.
Okay, let me catch up to Caleb. Because in red there were 5, and female there were 6. So 9 does not equal, so I'm going to slash, 9 does not equal 5 plus 6. So what could we do to improve that answer? 9 out of 17 equals 5 out of 17 plus 6 out of 17 minus, what do we have to take away
Middle.
to make it correct? Because this side is higher than this side, so what do we have to take away?
2.
All right, there's 11 on this side, 9 on this side, so I have to take away 2. But isn't it interesting, a 2 does show up in one of our categories. So that is how we are going to do that. The probability of red or female equals the probability of red plus the probability of female minus the probability of red and female. Notice the meaningful difference between or and and. That and is that spot where they overlap. Or could be on either circle.
That's pretty
So,
complicated.
that's a principle that we're going to use today. I'll put it up top. And the probability of A or, we're going to switch or, and it's going to be the union symbol. So that means or.
What?
It's red A union B, it means or.
I've
It's
been
really
using
not a
it.
U, it's a little fatter than a U, but that's how it looks on the board. Equals the
We use
probability
V's.
of A plus
use
the
V's. I've been
probability
using a
of
V this whole
B
time.
minus,
Like a little bit lowercase v.
Yeah.
now we have another symbol for the and
meant
it's
something.
the upside down.
That was
And
and.
it's red,
The side
this
with the
means
horseshoe was
and.
the therefore. If then.
No, if then.
Yeah.
Therefore,
It means and, but it's red
And
intersect,
3 lines was.
is how you read
I.
it.
Oh, yeah.
And this is red union. I'll put the or up top. It means or, and it's red union. A union B equals probability of A plus probability of B minus the probability of A intersect B.
Wait a second. Do we
And
have
this
to
is-
use these symbols?
Pardon?
Do we have to use these symbols?
Oh yes, you have to, they show up. Yeah. I always think of them as and or.
But they're not the same as the logic symbols.
They
Why don't
are?
just make them the same. No.
Yeah.
Really? What are they in logic?
Logic, it's like a lowercase v means or, and the dot means
A
and.
dot.
Of course, the dot might be confusing in math because it's multiplication, but at least the plus would be good. Like, oh.
Interesting.
Yeah.
Okay.
And then the sideways u was like if then.
Now, I was wondering, and I'm sure you were as well, this is non-mutually exclusive events. Does our formula work for mutually exclusive events?
Yes, because the r and f would just be 0, so it doesn't
Oh,
matter.
very good. I love it when you see where I'm going. All right, let's show you where. Catching up with Caleb again. Say we have mutually exclusive events. What were some that you had? You had dead and alive. I think there's some creatures out there that we're not sure which they're in. You took biology.
Ooh, I have a good one.
What were they? Viruses? Like, are they dead or alive? So
No, but
we're assuming that they have settled.
They're
in one
alive, but
different-
they are death.
You either like pizza or you are crazy.
All right. So the probability. Well, since we don't have a number for these, I can't
No,
use that
you
example.
can.
Yeah,
How
some
about
people are
rolling?
You can be crazy and like pizza.
Rolling a 1 on one die and
So-
rolling a 6.
They're not mutually exclusive. They're just.
I had to
Yeah.
drop the dead or alive,
Yeah.
dead and alive scenario because I didn't have numbers. So, what's the probability of rolling a 1 or a 6? We're wanting to see if this formula works. I'll put and. Alright, so probability of 1 or a 6 is the probability of a 1/6, rolling a 1 on one die, and probability of 6 is 1/6. And Caleb, what's the probability of rolling a 1 roll? What's the probability of getting both a 1 and a 6?
The probability is 1.
No, you already told us, a 0. So, we get the probability
Every time.
1 or
So we'll have
6
to get a
is
plus 1
2
and
6. Does that equal 1 6 plus 1 6 minus 0? It does. So our formula works for both mutually exclusive and non. Because when exclusive, this is 0. So you can see it clearly on the rolling the die sample. The formula works for both. All right. We are going to come up to the board now. Can you please come up and give yourself a third of the board?
Recording still?
Yeah, we're gonna do some board work and we're gonna show you our results in a few. So be right back.